Okay. Let's see. All right. I made it so my face isn't weird. I mean, it's a little weird, but not overly weird. Okay. So y'all can hear me? Everything's going well? All righty. We've lost 2 people. They wrote me mean emails and said they hated me. No, they didn't. They said they couldn't make the rest of it. So we will see them again tomorrow. Okay, so one thing about bivariate regression that I always like to emphasize is which things are scalars, constants, in other words, and which things are variables. So we have this little like y sub I. That's obviously a variable because it's just the actual values of the variable, the dependent variable. What about A? Is that a constant across, Alberto?
Yes, that's a constant. That's basically, it's also known as the intercept and is the value it takes when everything else is 0. Correct me if I'm wrong.
Exactly. And it's exactly 0, which is why it's sometimes helpful to do what some people propose in multi-level models and center all the variables so that you understand that the intercept represents the predictive value of y when every variable is at its mean. And that's super helpful. Okay, B. What I like to say about B is in the the Judea-Pearl types who talk about causality a lot. They talk about macro causality. And they say causality does not happen at the individual level. What do you suppose they mean by that? Because that's kind of weird if we're like testing the effectiveness of a medicine and we don't think about causality at the individual level and that it's only macro, like in aggregate. And that's because B is a constant, right? Like B represents the effect of Y across everybody, right? It's like it describes the population. It intends to describe the population. And whatever population you're generalizing to, because if you have pancreatic cancer, you want the medicine to cure pancreatic cancer among people who have pancreatic cancer, right? And so it's like that. But it describes the causality across all the units. And so then they try to get specific with heterogeneous treatment effects to find out what's the effect of gender. And so there's multiple ways of getting at that. So we'll get to that tomorrow. Okay, X. Constant or a variable? Obviously, it's a variable. Okay. All right. E.
It's the error term.
Yeah, is it a variable or a constant?
It's made with a
yeah,
lot of variables actually, so it's
huh?
not a constant.
It's not a
It's
constant.
like it's not a constant.
That's right. It's not a constant. So if you're doing OLS regression, we expect a mean of 0 for the residuals. Is that an assumption or is that a fact?
An assumption.
It's a fact. Now, the assumption is that the mean of the residuals is 0 across the values of X. And if that's not true, what OLS assumption have we violated? Like if we save a residual and we run a sum, you'll get a mean of 0 every single time, regardless of regression. But the question is, like, if the mean of the residuals is not 0 across the levels of X, what is that one?
So we violate the assumption of the exogeneity of the parameters. So if it does not equal 0, we have endogeneity.
Spherical errors.
I think if the exogeneity is whether the error term is correlated with like some omitted variable, right? That because you save the residual as a variable, you can test to see, is it correlated? What's it correlated with? If it's correlated with stuff, then you violated that one. So this is a different assumption, that if the mean of the residuals is not constant across the values of X.
Homoscedasticity.
That's the one, homoscedasticity, right? If the error terms across the values of X are correlated, then we've got the independence, right? The independence of the units violated. Now, do you suppose we have a violation of the independence of units when we just are analyzing survey data? Like, what do you think Anand would say about that? And I don't mean because he taught you data 1, I mean because of his research.
If it's about network, everything's correlated.
Right? Like, people in the survey are representing people who talk to other citizens, right? Like, I got basically, I mean, this is an extreme way to put it, but I got kind of radicalized by my Facebook friends who want to torture innocent people, because I'm like, what in the hell is wrong with you people? Like, I was like, I want to distance myself. So I became even more kind of extreme, than I already was, because I just was like, I want to be not that, right? Like, I was affected by the kind of conversations that were happening across the country, right? And so I was being affected. I'm representing people, survey respondents were probably also talking to their crazy relatives or whatever, and then becoming a little bit more radicalized or something like that. And so there's problems with that. But I always like to get the assumptions in terms of practical, so that you understand, because you just read these papers. I don't care if it's from somebody who's been practicing in the field for decades. And one caveat I might say is that my error term might not be homoscedastic or whatever. And it's like, give me a fucking break. Tell me what about the lack of homoscedasticity is causing a problem here? Because probably, and maybe this is like an assumption that I make in life, there's something causing that heteroscedasticity. It's not a problem. It's a failure to account for something, which is often the lack of interval, level measure in your scale or whatever. Okay, so nevertheless, it's kind of fun to think about things like that. All right, so the variable E sub I gives us an estimate of the average error, and another name for average error is standard error, right? It's kind of similar to a standard deviation. If you look at the like I call it a sum, but that's a stated term, a descriptive, mean standard deviation of your residual term. It's not exactly the standard error, but it's analogous to the standard error. And so if I run this regression, so this is support for the rule of law predicted by, do you think police should treat minorities differently? And there's I would say, quite a strong correlation. If you think police should treat minorities differently, you have lower support for the rule of law, right? You just want to get the shit done and just, like whatever those racists are thinking, make me feel less comfortable or whatever. And okay, I will get into it. But this variable ended up being quite interesting. All right, so here's a residual from a more highly correlated IV and DV. Now, what do you suppose the correlation is between the residual and the actual DV? Even when you just carved out some portion of the variation and given it to another variable, what do you suppose the correlation is? Well, why don't I just tell you what the correlation is? I've got some things here. And then you have one where like that T was like 12 standard errors, differentiated from 0. This one is 4 standard deviations from, or standard errors from 0. And so then you get more residuals near the tails. That other one was negative 0.5 to positive 0.5. This one's negative 0.6 to positive 0.4. But wait a minute, I thought the mean is supposed to be 0. It is 0. We just have, more negative ones over there. And that's, there's more between 2 and 4. And then these things balance off by being that. So this sort of shows you it's not homoscedastic, right? Just looking at it, you can tell that, it's not. Okay. All right. All right. So I want to talk a little bit about R square. The reason I want to talk a little bit about R square is because we're going to end up doing some tests that use R square. So it really is important to really kind of get an understanding for what it is. So when we do statistics, if you just have one variable, what is your best guess as to the value of that variable? The mean, right? You just have one variable, your best guess. Like if I put you, took all of your heights, got the mean, put you all outside the door, and then, you're going to walk in it each time, and I have to guess your height to minimize the error. I'm going to guess the mean every single time. I might reduce some of that error by knowing gender or something like that, right? So we want to do better than the mean. That's basically it, because when we are not doing any better than the mean, your slope is 0, right? Okay, so a note about variation. So I have here this variable, which is, can y'all see that? Can you read like the bottom x-axis? Oh, so it's just me, I can't. Okay. This variable is how much do people hate the other party? And everyone is just maxed out. It's like these people are just like, fuck those people. And this one is like party identification, in which there's a ton of variation, right? If a variable is more constant, when there's less variation, it is less able to predict things, and it's also less able to be predicted. And you can kind of see that if you look at some Venn diagrams. So here you've got some similar variation. Here you got a lot of variation of X. Everybody loves high variation of X. KKV and all those people love like high variation because there's more stuff to explain. You can put in more variables, you lose degrees of freedom less fast. But like if your X has a tiny bit of variation or your Y has a tiny bit of variation, they're all competing over very little variation. And I know this because I have a published study in which my N is 300 and my variable is dichotomous, where one category was 8% and the other category was 92. You know, and that's just that you're running out of degrees of freedom super duper fast on that one. So it's good to be mindful of that. Okay, so I'm going to be talking about some various causal models here, and I'm going to go through some kinds of causality. So you have just straightforward linear causality, and then if you have a third variable, like a second independent variable, it might just be another cause. It might also contribute to explaining some of that variation. Or you might have a confounder, or you might have a mediator, which doesn't necessarily mean you've got the true mediator, but you've got a mediating model. And I'm the only one who makes a distinction there, but the way other people go about making that distinction is irritating to me. And so I'll go over that, but let's do some Venn diagram fun here, because I'm going to get specific about what statistics are inside these Venn diagrams. So I love Venn diagrams. I think they're so fun. So we've got some fun ones here. This one is amazing. You've got intelligence and social inaptitude. You got dweeb. You know, we've got some fun things here. People who care about the distinction between geeks and nerds is like, you're both. Bono can't live here. Anyway, there's some fun ones. You can look at them later. What's actually going on inside these Venn diagrams is, okay, so X is my variable that I care about, or your variable that you care about. Z is the fucker. Not always a fucker, but sometimes gets in there and goes, not so fast, Mr. You know, causal inference or whatever. And Y is what you're trying to explain. And this part in the middle here is the part that virtually no method can tear apart. The only exception to a method that can kind of get at that, like, I don't know what it is, like a diamond in the middle. It's just like you can't crack it, is two-stage least squares or some kind of structural equation modeling. But otherwise, I don't care what kind of method, logit, you know, whatever method you're trying to get at, you're not gonna tear that apart. Multiple regression is just fucked of every kind. You can't do anything about it. But where this space is where X is high and Y is high, but Z is low. And this orange space is X is high and Z is high, but Y is low, and vice versa, right? And this purple part is where Z is high and Y is high, or Z is low and Y is low, but X is high. And that's where you can capitalize on using that information to give independent effects. That's what multiple regression is doing. Every kind, maximum likelihood, GLM, all of them are doing that. All right, so here's R, right, or R square. And by the way, Pearson R square is R square in the bivariate case. Just a little factoid for you. And this is, you know, the unique variation, and is equivalent to the multiple regression beta or B, or, you know, however you want to say. R square includes this diamond here. They don't know where it comes from, but because it overlaps with Y, it's part of R square. So that's important to understand F statistics, which we'll talk about in a minute. Okay, so spurious correlation. So here's a big misconception, so I'll get it out of the way. When you have spurious, when you have a confounder, do you have to establish causality in order to identify a confounder? And the answer is yes. Okay, it's a very specific causal situation in order to say, okay, that one's a confounder, okay? So A and B are spuriously correlated if they're correlated, but you control for Z and that disappears the correlation, right? But in order to be a confounder, Z must thought to be exogenous to both Y and X, okay? If X is exogenous to Z, or you don't know, you don't really know if it's a confounder. And this becomes important with heterogeneous treatment effects and when you can control for post-treatment covariates. Okay, so I'm going to move past these, but this is basically what it looks like, right? You've got A and B correlated. You look at just low values of Z and it loses it. You look at just high values of Z and it also loses it, right? And so if it's entirely confounding, this is what you'll see, right? In addition to Z causing both X and Y, it disappears the correlation. And usually stuff is like partially confounding and that kind of thing, okay? Okay, so here's a good one that was found in the literature, because I hate all the dumb examples. So this is one that was actually found in the literature. So does education contribute to political tolerance? And people say the causal mechanism is you go to college, you get exposed to new ideas, blah, 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 socialization to the dominant framework, whatever, that kind of thing, right? And so everyone looks at that. Well, two people came along and they're like, you know what? I bet it's actually intelligence. All right. It's actually just cognitive sophistication. Do any of y'all know which survey actually has all the measures of intelligence are terrible, and this one is particularly bad, but they do estimate, they do ask these people a bunch of SAT type questions. Does anyone know what survey that's on? The GSS. The GSS is the richest data I have ever seen in my life. I mean, world values is like crazy, but I mean, GSS is insane with exogenous variables. I mean, it's crazy. All right. So what do you think about causality? Does this Z seem to be causing both? Like, would you say it's exogenous to education? And why would it be? Why would cognitive sophistication be exogenous to education? It's more because we test people for their, ability to do well on these exams. And then we let those people into college and deny everybody else, right? Instead, we should be, denying the sociopaths, although they got to live their lives too, I guess. But, so the idea is that maybe education makes people smarter. I'd like to think it, we have some impact on, helping people sort that out or whatever, but there's a selection mechanism that causes that, right? So here's what they found: regular correlation between education and political tolerance. And then they control for IQ. Now here's how it works, right? You just, high IQ there is simplified into the red, low IQ is simplified into the Y, and then you draw slopes for either one, and now you've got a flatter slope. And they accounted for actually quite a bit of the variation. So like, it teaches us something about like, how do we go about having an impact on making people not want to repress their fellow man is to actually give them resources to have a sober second thought, or, and not just assume that education is going to take care of it. Maybe it teaches us that. I don't know. But I thought that was kind of an interesting example where we always use, spurious correlation is always like the storks and the babies, or the fire trucks and the fire damage. Have y'all heard all those examples? They're idiotic. And like, I like examples where smart people have fucked it up, because that actually teaches us something. So in any case, I thought that was kind of an interesting one. So here's a bad one. Okay. So, and I'm being unfair to the author of this study. because he knows about this, but I'm just like using it as an example. So this person wanted to know, does truth cause reconciliation? And he looked in the South African case and figured out what the TRC, what the truths were that came out of that process, and wanted to know people who accept the truth, are they more reconciled? Okay. I want you to tell me what this looks like. Measures of truth. Apartheid was a crime against humanity. Bad people on both sides. The abuses under the apartheid system were committed by a few evil individuals, but not by the state institutions themselves. That was false, right? Like, so that, there's some conclusions that the TRC reached, okay? Now we've got measures of reconciliation. So the measures of truth were, yeah, the struggle to preserve apartheid was just, yada, okay? Measures of reconciliation is, I don't like those people, they're weird, they're untrustworthy, they're selfish, I'm uncomfortable around them. Like, it's like, basic, I don't like those people, racial resentment or fear or however you want to call it, right? They're reconciled. And then they look at, okay, so there's variance of reconciliation, there's a variance of truth, and then there's the variance of, I didn't like those people before, and I still don't like those people. And if you're not accounting for that, then the TRC did not bring about change, right? If you're just connecting racism with racism, if people who are saying apartheid is just, they're probably racist, right? And so the racism is then causing them to be either reconciled or not. And the racism was causing them to believe in those truths or not, is an argument. And so it's entirely spurious, in my view. It doesn't defend a TRC. Now, you can defend a TRC on other grounds, but the policy intervention may not have brought this correlation about. That's what I would say. Okay. So it's a spurious correlation. And if you don't account for the racism of the person in general, then, you're not saying very much. I mean, basically, this is a way of saying Y equals Y. Oh my God, I can't believe it. Y equals Y. One measure of Y equals another version of Y, which is, a lot of what people do these days. I mean, Calmo and Mason just published a book talking about political violence in the US, and they found the shocking finding that people who are willing to dehumanize, people of the other party are also more willing to do violence against them, And to me, I haven't learned anything there. Maybe I'm being too harsh. Y'all look at me like I'm being too harsh. Okay. So the relationship between truth and reconciliation, if you look at only the racists, they're not reconciled, and if you look at the non-racists, they were reconciled to begin with, is the way that would work. Okay. So here's a super fun one. Okay. I love this story. So I'm writing a textbook I'm writing a kind of a stats textbook, Daily Bob, kind of statistics, but then examples of where statistics got misused by smart people, not by dumb people. And here's a great one. Okay. So when I'm talking about a mediating model here, I'm not talking about the true mediator. That's a different question. But the existence of mediation happening in the model has to do with, well, why don't I just tell you? Okay. So here's a finding, and this is true. This finding is literally out there. They found it in the 90s. And they were like, we've been trying to study rheumatoid arthritis in memory care facilities because that's where the old people are, and they're a convenient sample to understand rheumatoid arthritis. And we can't find anybody who has Alzheimer's who has rheumatoid arthritis. Rheumatoid arthritis is non-existent in these populations, and it should be 10-15% of those populations given their age. And so they like wrote a letter to the editor and a neuroscience. They were like, we're not trying to say that this is causal, but we're just trying to maybe, like they're like tripping over themselves. We're just telling y'all about it. We're not trying to claim anything here. Like they're, because everyone's so afraid of their own shadow with spurious correlation, but like, it makes no fucking sense, right? And here's another thing I tell you. We knew nothing about Alzheimer's before this little crosstab was posted in a letter to the editor. Zero. We put these people in facilities to die. And that was it. There were no treatments. There were no guesses about what caused it. And then they're like, maybe, there's something to this, right? So can anyone guess what it might be? Because there's no possible way that rheumatoid arthritis in and of itself prevents Alzheimer's, right? Like, I mean, maybe. And in fact, now they're kind of thinking there's something there because they can't get rid of this correlation. But the correlation is like -0.6. I mean, it's just non-existent. What the hell do you think this is? I know it confounded them too, because they're like, we don't know, but there's obviously something. Okay. So they're like, well, wait a minute. It can't be this, right? And, it can't be that Alzheimer's, somehow, prevents it, like it just doesn't make any sense. There has to be a variable Z that rheumatoid arthritis causes, which then in turn causes Alzheimer's. Now, what do you think? Is anyone thinking? They know? What does rheumatoid arthritis cause? Behaviorally. As people are walking around their life, what does it cause them to do?
Less mobility?
Well, maybe. Okay. So that is a good thought. Like there's less mobility. Like my pain caused me to write out a big old spreadsheet and figure out what the hell's going on with, I have it, then I don't, then I have it, then I don't. I'm doing something right sometimes and not other times, What do people who have rheumatoid arthritis do? Probably every day. They take an action that has been found to prevent Alzheimer's. I know, it's hard. The best minds of the world were on this, so you shouldn't feel bad. Ibuprofen. They're taking ibuprofen. And it turns out that because of this little bitty crosstab that these people presented, they found out that Alzheimer's was a disease of inflammation. Now, is that not cool or what? And literally everything we know happened like 2 years later, big grants coming from people, who are reading that neuroscience journal. They're trying to investigate. And turns out you can't give people ibuprofen when they get Alzheimer's. You have to have taken it your whole life. They tried to experimentally manipulate it and it didn't work. And there's been, a bunch of studies trying to figure out. And then they're like, we cannot reduce this effect to zero. So maybe there is something to rheumatoid arthritis helps the plaque in the brain or something. Like now they're trying to test those hypotheses. So science keeps going. But because somebody printed an obviously non-causal relationship, or at least it looked really stupid or whatever, and they're all apologetic about it, that therefore we know everything, So I'm always like in defense of spurious correlation, because probably something's going on. There could be some clue about what's going on when something doesn't make sense. But that's just me. But it's obviously not ibuprofen causing rheumatoid arthritis. This is not a confounder. This is a mediator. And mediators are great instruments. And anyway, here's one And you know, when this hit the news in the early aughts, cities across the United States and Europe took fluoride out of the water because they're like, well, fuck me. Obviously, fluoride is causing cancer. Okay. The units of analysis here are cities. Okay. So what do you think is going on here? That is not necessarily causal. Like, where are people getting cancer? And it's actually sad, you know, that they're not getting cancer, if that gives you a clue.
I was just going to say potentially because if it is a city, they're more exposed to you know, just general pollution compared to like.
Oh, okay, that's an
areas.
interesting thought. That's an interesting thought, actually. That's an interesting thought. And maybe that's the case too, you know, that those cancers are being caused by other things. You know, and there are some like micro level studies where they've looked at people who accidentally ingest a ton of fluoride, like they ate a bunch of tube of toothpaste when they were 3, and then they're more likely to get bone cancer, you know, so high levels of fluoride all at once is associated with, but these are micro doses, right, of fluoride. So the question is, where, think about in the world, places that sadly are not getting cancer. In the 90s. Poor cities, right? Poor cities. I mean, sub-Saharan Africa, the life expectancy just, I don't know, have y'all ever watched Hans Rosling's The Best Stats lecture you've ever seen? Oh my God, it's giving me goosebumps thinking about it. It's so good. But like one part of it, he's showing the life expectancy just plummet in sub-Saharan Africa for a while in the 90s. I mean, just people were dying of AIDS and massive, massive levels, you know, and they're not getting cancer because life expectancy is too low, and they're not fluoridating their water because they don't have the money to fluoridate their water, or they're not having good access to clean water or whatever it is, you know. And so turns out, and they're not also diagnosing cancer. So people might be getting it, but if you don't have good diagnostic instruments, you're not even finding out if you have cancer, right? So cancer rates are low. So wealth is causing that. And is that spurious or is that confounding? Is that a confounding or is that mediating? Is wealth causing both, or what? I know it's not that easy to you have to think about it for a second. It's not wealth, you know, it's not fluoridation is causing wealth of a city, right? It's wealth causing the fluoridation. So it's a confounder, you know. So here's the, you know, fucked up news is that confounding and mediating processes are observationally equivalent. Have y'all heard that term before, observationally equivalent? You cannot distinguish a confounding effect from a mediating effect, you know, statistically speaking. You have to understand which variable is exogenous. Now, where that becomes important is in disease risk ratios. If being male increases your likelihood of getting diabetes, which it does, then if you control for age and, you know, other things that are associated with being male, higher drinking, higher whatever, there's other stuff that's, it's not anybody male or female here on the call that, you know, does anything like, I'm not trying to, you know, but men are more likely to get diabetes. And if you control for the factors, the reasons that they're more likely to get diabetes, you're going to reduce the effective male. And that is not a good idea. So you should not correct coefficients that are mediated. And it has nothing to do with the true mediator. Like maybe I need to find a different term, but because everybody's all about true mediators these days. But like if you've got an exogenous coefficient that is reduced in a multiple regression, you shall not, it is a cardinal rule from today forward, correct your estimate of that factor. Now, sometimes you can't tell which thing is exogenous, but then be aware of it. If I have my, wishes, everybody would report bivariate in addition to multiple regression. That way we know, because everyone's like, you better not control for a post-treatment covariance. And it's like, why not just report it both ways? Then everyone's happy, then we understand what's going on. But, nobody listens to me. So, all right. So spurious regression looks like this, and an intervening or mediating relationship looks exactly identical. So be aware of that. So, so here's the thing that is not observationally equivalent. Race, or being white versus not, causes education, which causes income, which is, it's an unfair way to put it, because racism causes this whole thing to happen, right? So it's, and the fact, San Antonio versus Rodriguez, or, yada, yada, which is irritating. But nevertheless, look at these two different models. You got being white causes education, which then causes income. And you got being white causes both income and education. Which is, if education completely reduces the effect of race, is that a better world than this one, or a worse world? Because I'll tell you what world we are. You control for education, and it has no fucking impact on a person of color's income. And that's a bad world, as I see it. It's a sad world. You shouldn't tell your undergraduates that, because it make everybody depressed. But maybe you should at least tell the white ones, which is like most of our student body or whatever. But like that, it's, it would make me depressed or sad, that, there's nothing much you can do. Of course, it's just, averages or whatever, but, it's a fucked up thing. All right. So here's where we get into like more complicated causal models that we'll be talking about when we talk about experiments. So like, here's an interesting causal model that is political interest is a function of actually your mother's interest. And if your father or second parent is also interested, all the better. But, your people kind of develop a political interest in early age. And Marcus Pryor has written a book that shows that in panel studies, he's able to find that after you're 18, participation actually causes your interest more than the other way around. It's kind of interesting. So people talk about the relationship between political interest. If you're interested, you get to know stuff about politics, and then you feel like you know something about politics, which is self-efficacy, which then causes participation. But if you don't control for whether you started voting at a young age, then this is all fucked up, because what happens is you get habits, and those habits also cause self-efficacy. So if you're not controlling for what people did when they were 18, 19, 20, 21, earlier ages than most of you all are likely, then you're going to overestimate the impact of political interest on participation, which turns out not to even work that way. I mean, it turns out that, and I'll have to tell you all about this when we talk about the experimental treatments, lowering the voting age disenfranchised young voters forever. And in fact, accounts for the decline in voter turnout in Western European and North American democracies. It's insane. Like, we tried to get people to vote by lowering the voting age. And because of this model, it actually lowered their likelihood of voting. And young people from then on quit voting. So it's a great multi-level model. All right. So we'll talk about that later. All right. Oh yeah, this is, so the question is, do you correct? You correct confounders, but you don't correct mediators. And if you don't know which one is which, then it's problematic to know what you correct, So that's something to be aware of. So are y'all super aware of Simpson's paradox and suppression and how that works? Or does anybody know what it is? I thought so. So I'm glad I'm bringing it up. Okay, good. It's important. All right. So there's some classic examples of this, but I'm going to give you my example of this, which is that everybody knows that the death penalty is racist, right? At least everybody on the call knows, the death penalty is racist. So then we should be aware that Black people are more likely to get the death penalty. It turns out it's not true. You've got being Black is negatively correlated with getting the death penalty. And you're like, why are you telling us this? This can't be true, right? Like, it's not strong. Pearson R is -10. So it's not strong, but it's the opposite from what you would expect, right? So what the hell is going on here, right? To me, I'm a little bit like that. Okay. And you should be too. And here's the, stats on this, that if you're white, your likelihood of getting the death penalty, just straightforward statistics, is 9%. If you're Black, it's 4%. And this is Missouri data, but Missouri is just as racist as the rest of them. And so it's like, why? Can anyone think of why this would be the case? I know it's not that easy. Even if you're a judicial person, it's not that easy. All right.
Could a possible explanation be the population density period? Because white folks are much more of the population than Blacks.
Well, no, because the Pearson R controls for that, right? So it's a proportion of that population. So we got Black capital crime defendants are in the 6,000, whites are less, because of racism. But then of those 6,000, the probability of getting death is lower than white. Well, that's this one. These are just the straightforward percentages, So of these people, they're more likely to get the death penalty. And of these, they're less likely. Has anyone ever seen that movie? What's it? Matthew McConaughey, where, he's describing a horrific crime and describes it. And then at the end, he says, now imagine that this victim is white. Right? And everybody's like, oh, turns out whether you get the death penalty doesn't depend on your race. If you're the defendant, it depends on the race of your victim. Now, why is that coming into play? Well, that comes into play because Black people kill Black people and white people kill white people. I mean, that's what the fucking racists on Fox News don't realize, is that the Black on Black crime implies that there's white on white crime. Like, that's the other part of the crosstab that they're forgetting to talk about, is that white people kill white people and Black people kill Black people. And why is that the case? Because people kill people they know. And we live in a racist, segregated society. So Black people are more likely to know Black people and white people are more likely to know white people. And honestly, like, when you kill someone, even if it's a capital crime, you're less likely to get the death penalty. So once you account for the race of the victim, okay, if you account for the race of the victim, now when Black people kill white people, they're 15 times likely to get, they're way more likely to get the death penalty than white people who kill Black people. Look at that. White people who kill Black people are 1/3 likely to get the death penalty. And this is suppression. So controlling for a third variable does not mitigate the relationship there. It changes its sign. It makes a zero relationship not zero suddenly. Suppression can do all kinds of things. So now you take into account I've got betas here because this is an old slide here, but race of the victim, if you kill a Black person, you're less likely to get the death penalty. But then if you control for that, now race of the defendant is suddenly statistically significant, where Black people are more likely to get the death penalty. So it changes the nature of the coefficient. Okay, so let's talk a little bit about interactions, and I'm going to skip this one, even though I like this example. I'm going to skip it anyway, and I'm going to show you some cool, fun interactions here. Okay, so interactions are not at all observationally equivalent with confounding or mediating. Confounding or mediating processes, a mediator or a confounder mitigates the other variable. In moderation, I mean, like let me ask you this. Can two variables who have a zero correlation yet nevertheless interact to change the outcome? Variable X is zero correlated with Y. Variable Z, zero correlated with Y. Can those interact in a way that is statistically significant? Yes, absolutely. Absolutely. So it's something to be aware of. Now, everyone likes to plot interactions. My wish is that people would be taught to look at a table and figure out what the things would be. But I don't know. Did y'all do that in Data 1? Where you look at the table and you actually calculate what the effects are without looking at a graph? It's kind of good to do. But here I've got, y'all can probably see this better than I can. Oh, right. The interaction between dogmatism and perception of an economic grievance, which is, by the way, uncorrelated with actual economic grievance, which is kind of fun for my story. But if you're not dogmatic, then your perceived economic grievance does not increase your support for political violence. But if you are dogmatic, look at the magnitude of the impact there. Every variable is coded 0 to 1. You start out with low dogmatism, low economic grievance. These people just don't want political violence at all, right? And if you have both, now your predicted probability is a 0.7 for a variable whose mean is like 0.4. Like, this is, to me, astronomical. It's like there's no daylight between those, between those slopes. So those slopes are very different. Okay. Here's how often you feel anger and hatred in your daily life. Non-political anger and hatred also exacerbates dogmatism. And this is its impact on the loss of agency or the lack of agency. If you're not dogmatic, the loss of agency doesn't increase your support for violence. But if you are dogmatic, it really does. And this kind of makes sense, right? But dogmatism is not that strongly correlated positively with support for violence, but it interacts like fuck with every other variable. And you know what other variable interacts like crazy? Optimism. Disappointed optimists are the most violent people, you know, and I know because I'm an optimist, you know, when I'm disappointed, I'm fucking pissed. I don't know about y'all. When you're a pessimist, you're like, yeah, that's the world I expect, right? Or something about optimists, you know, same thing with empathetic people. Empathetic people are very violent. You know why? Because they're protecting their people. You know, it's like white racists who have high empathy are like, but my white people, you know, so they're, you know, and it's not good empathy, but nevertheless. Here's a fun one with taking COVID seriously. And here's a pretty, to me, I love this because you have a rug plot that shows the different levels of each category so that you can see. I mean, you got the red confidence interval, which is wider, which is because there's not very many red, you know, there's not very many people in the red condition. But here's this first graph that my undergrad produced in my designing social inquiry class, and we just submitted it to a fancy epidemiology, the fanciest epidemiology journal, because we're like, what the fuck? Locus of control, the more locus of control, the more you're supposed to take COVID seriously, right? And so it's like, but we find that the less locus of control, the more you take it seriously, but only if you're a Republican. And, you know, I'll have to tell you about this on another day, but our argument is that everybody who's looked at the correlation between liking Trump and party ID has it wrong, and that we found a confounder. So if you want to talk about that, I'll tell you after, you know. All right, so here's the thing I want to do, because I want to explain what's going on under the hood in multiple regression, because I feel like that gets a little bit swept under the rug. So here I've got a low Venn diagram here on support for the rule of law, feeling out of control, that other variable that I just described to you, and perceived grievance. And we already know that these are strongly correlated. Grievance has a strong independent effect on rule of law, and out of control has a strong independent effect despite their strong correlation, okay? And then you've got this negative 33. That's the part where it's just grievance and the rule of law is the orange. And then here's the part we can't break apart. It's like a diamond. We just, nothing we can do can take that apart. Same thing with this is the green between the two. This is the B coefficient. And what coefficient is indicative of this diamond here? Where is that in a multiple regression output? What would Andy Phillips tell you? When you have high multicollinearity, you have high. What? Really? No one? Are y'all tired? Yeah.
Is it standard errors?
Standard errors. You blow up your standard errors with high multicollinearity. Okay. So what I did here is I did a little fun thing. So I so here's what to understand the independent impact of feeling out of control, what I do is I create two variables, a rule of law that is not a function of grievance, and out of control that is not a function of grievance. How do I do that? And I don't mean give me the code. I mean, like, you know, in principle. What might I do to create a variable that is support for the rule of law that is independent of grievance?
So you run a regression, and then whatever is left, like residuals, that becomes your regression.
Exactly. This is a run a regression, save a residual. Okay. So I ran a regression on out, and I predicted this variable called abs not out, you know, and then I run a regression, So this is like abs not out. This is what it looks like. Okay. Residuals are not the same thing as a dependent variable, but they're correlated at, I don't know what they're correlated here, but they're correlated probably at 85. You know, they're very highly correlated. Okay. Because it's itself with a part of itself. If you lose your arm, you're still yourself. So it's kind of like that. Okay. Then I take the part of grieve out of out and I save out, not grieve. Okay. Out, not grieve. Then I run a bivariate regression between those residuals. All right. So who can I give an assignment to, which is to remember -16. Stephen, you look like you're a good memorizer of -16. Don't worry, I won't pick on you again for this example. All right. Now, then if I run a regression of out on abs not out, the probability that that correlation is 0 is 1.0, right? Because it's not itself, right? I like to think about regression that, like, for instance, if I've got a regression of support for the rule of law and I'm controlling for dogmatism, authoritarianism, and religiosity, then I'm taking the dogmatic and authoritarianism out of the religiosity variable. What's left over? You're like sweet Aunt Sarah or whatever. Like, you know, they just go to church because they like, you know, they like the potato salad and the friendship or whatever, but they're not out there to bust anybody's balls or whatever, right? You've taken the ugliness, that's my normative opinion, out of religiosity. What's left over is the non-orthodoxy, is the, like, you know, potato salad seeking folks. All right. So now I've got abs not grieve, right? I take, you know, grieve out of abs, and then I take out of, and then I take grieve out of out. Okay. Then I run another bivariate correlation, out not grieve on abs not grieve. And okay, Gustavo, this time I'm going to pick on you. Can you remember -23? All right, excellent. Okay. Now I just run a multiple regression with all three, and that's what that is. So it's a bivariate regression between the residual that's left over, is basically what multiple regression is. All right. These coefficients are identical to our bivariate case. I don't know if that helps you understand kind of what's going on under the hood, but here's some, you know, some other stuff. So here's some fun correlations between them. Grieve and grieve not, and abs not grieve, 0, you know. Here's some other ones. Abs not out with abs rule of law is 93, right? So it's very close to themselves when, you know, despite taking a lot out of it. Grieve not out, those are more correlated, so that's 90, you know, but still these are pretty highly correlated. All right, so here's some fun. Oh, right, there's two kinds of multiclinearity. There's the kind where the two independent variables are highly correlated, and so they, you know, that diamond becomes big and their independent effect can get smushed out, which is what happens when sometimes we try to control for post-treatment variables. But there's also the kind where well, shit. No. There's the kind where one is extremely correlated with the dependent variable, right? It takes too much out of the dependent variable and doesn't leave anything left, you know? So like when you're controlling for a variable that is essentially the same thing as the dependent variable, nothing else gets a chance, you know, to have an impact. Y'all seeing that? Okay. So identifying the presence of confounding or mediating, this is what the correlation matrices look like. You're going to have all positive or both are negative, but the IVs are positive. And if you have this, then neither IV1 nor IV2 can possibly be a confounder or mediator. If one of them is not correlated with the dependent variable, or if they're not correlated with each other, they cannot. They literally, I mean, maybe you've got bad data or something, that's another question, but they cannot mediate or confound one another if they're not correlated with both each other and the dependent variable. Okay, it's just a statistical impossibility. So here's an example where people are just desperate to find a confounder or a mediator. They want to find what causes people to believe that the people they don't like, you know, whoever they list that they don't like the most, Nazis or Black people or gay people, you know, people always say, you know, who's your most hated group? People don't say gay people anymore, but in the 90s they did. 16% said gay people were the worst threat to American democracy. And so the question is, what makes people think that they pose a threat or they pose a threat to democracy? And we have not been able to find any fucking variable that is correlated with these variables. Literally, it's one of the enigmas. Books have been written trying to endogenize threat, and we cannot figure it out. So it's like one of the puzzles that maybe you could contribute to, or frame your paper in a way that is loosely conceptualized with this problem, right? It's a really interesting problem. But since we can't find a mediator or a confounder, guess what? If you don't control for threat, it has no impact on the other variables. How do we know? Because it's not correlated with any of them, right? So you can leave it out, even if it takes a big chunk out of the dependent variable, because it's not correlated with any other variable we're trying to throw in the model. We're good. We're good to go. We're not biased by leaving it out. Okay. So these ones I'm going to have y'all practice from home because we got stuff to do. All right. So let's talk about, like, in general, multiple regression. Okay, so if we look at this multiple regression table, I want to find out what's going on here. So I've got Black, white, Latino, other. So can you tell me what negative 0.04 means? Well, actually, you know, this is made up data, obviously. How do you know that? I've messed something up here with my made up data. What's the problem with the construction of those dummy variables?
Do you have a base category? I don't think so.
Exactly. There's no base category, right? And, you know, I kind of like to use white people as the base category, but sometimes there's reasons for doing it some different way. But yeah, so if there were a base category left out of there, Black would be negative 0.04 compared to the base category. Same thing with white, positive 0.04 compared to the base category. So that's something to be aware of. What I was getting at, and why I messed this up, is because I was getting at, just because these coefficients are 0, and are they 0? Because I don't understand. This is negative and this one's positive. So are they 0? Yes. But why are they 0? Because the T's aren't 2. Right? So we accept the null on these. But accepting the null here, or looking at coefficients of race doesn't matter, is not a valid conclusion, because race is exogenous. Now, maybe there's some reasons for thinking that race is not exogenous. I mean, what's kind of interesting is that, did you know that 1/3 of the American population identifies as multiracial? 1/3. 1/3. I feel like I have to say that multiple times. 1/3. Now, it turns out people who identify as multiracial but white first act just like white people. from what I can tell. And because I have a student who wrote her thesis about that. And people who identify as, Black or, some other race first and then white, they act just like people of color. So, and their decision to identify as one thing first versus the next thing second is endogenous, right? Nevertheless. All right. What do you think might have, out of this list of variables, what do you think might have mediated race here? If you take like white out or something.
Socioeconomic status.
Socioeconomic status, right? Can carve out a lot of that variation that race is meaning to explain, especially when you're talking about health, your socioeconomic status, you don't have insurance, a whole slew of things, just like somebody said earlier with the pollution and, that kind of thing, can carve out quite a bit of that. All right. So, why do you suppose the standard errors are so high for optimism and interpersonal trust? Do we have any optimists in the room besides me? You're like, I don't want to be one of those violent optimists. And it's like, you were mostly born with it, although it does change. But does anybody want to be an optimist in the room? All right, I'll be the optimist. So like, I am such an idiot when it comes to trusting my fellow humans. I leave my car unlocked. One day I was like, I didn't have my kids at home, but like this woman walks by, and she's barefoot and her feet are bleeding. She looks like she hasn't showered in days. And I'm like, oh my gosh, come on into my home. Let me help you, because it's like a human is suffering there. And she's like, I really want to party. Does anybody want to party? And I was like, well, I was going to give you a Band-Aid or what. And people are like, what the fuck are you doing? Letting a strange bleeding person like inside your home, like, come in and here's all the stuff. And by the way, I never locked my doors. I probably told her, I trust my fellow man, and it doesn't matter how often my fellow humans disappoint me. You can't tell me a thing about my fellow humans. Like, I love strangers. They're all my people. They're all people are my people. And then there's people who are not like that, right? And so why are the standard errors so high?
Optimism and trust, they are correlated. That's why.
Exactly. And they both cause health. I can't tell you if they cause health, but they're both found time and time again to be correlated with health. And one of the reasons that has just been sort of identified is that as people feel threatened by their fellow humans, that threat causes glucose to flood their system, which causes diabetes and other hypertension and shit like that. So like Black people who are around microaggressions all day, that happens to them because diabetes is very strong in this country among African Americans, and yet non-existent in African countries, despite wealth or whatever, you can eat whatever you want. We don't see it over there. So the argument is that racism is what's causing that diabetes, but also white racists have that flood of glucose and all that stuff, and they get hypertension and obesity and diabetes and all that stuff. So we're killing each other. Anyway, okay, so and you have to start wondering, like, what's underlying this? What is underlying the coefficient of socioeconomic status that we're not accounting for? Like the pollution and, bad education and shitty jobs where you have to have 3 jobs and the stress. And like, I was reading something about the consequences of being a first-gen successful person is that we're more likely to die early because of what we did to ourselves to get here, you know? Kind of fucking sucks, but okay. So, well, what did I do? Oh no. All right, well, I don't have a very good introduction here. But here's a nice paper written in the early 90s. So this is back when we were like Pearson R's and betas and everybody was pro standardization. And then Gary King wrote a book and everybody got allergic to standardized coefficients, but their beta is the equivalent of R in the bivariate case. So it's a nice comparison there. And here the person's trying to, Gibson and Caldera are trying to predict what causes people to believe that the Supreme Court is legitimate. And if you look here, they've got all these policy variables that are policies that the Supreme Court has decided: death penalty, racial segregation, gun control, all this kind of stuff. And we're not really seeing that much, like racial segregation, like the policy of allowing racial segregation to exist is slightly correlated, being pro-abortion, but these coefficients aren't much to speak of, right? You would think that, well, now being pro-abortion is super correlated, but then it wasn't, okay? And so like, this is what that does. They look at all these policies. These policies are correlated with one another, right? So you've got some Pearson R's that are, you know, somewhat strong, but racial segregation and abortion are the ones that end up being independent because they're the ones that kind of aren't correlated with the other ones as much, you know? They've got some independent, like these are the racists and these are the religious racists. I don't know, something like that. The religious non-racists. Then they want to look at like trust, satisfaction with life, confidence in institutions. And we basically have a big nothing burger here. Zero in the bivariate, basically, except for trust in their fellow man. But trust in institutions, trust in other institutions, trust in Congress is zero, even in the bivariate case, okay? Then we've got, like, here's interpersonal trust and everything else is not even correlated at all. That's what's happening there. And then you've got like political information, like attentiveness, interest, activism, all have pretty strong Pearson R's. But the only real significant ones there are attentiveness to the Supreme Court. How much do you pay attention to it? You know, and this is where we got this theory that we call the myth of legality. The more people think they know about the Supreme Court, the less they know about the Supreme Court. It's kind of a puzzle there. Why do you think they constructed their paper to look at policies and then trust and satisfaction and confidence and stuff like that as separate from political information? Why do you think they did this thing in steps like that? Because they're kind of trying to identify the things that are most likely to be correlated with one another to find out what is going to be the big, we used to call it the horse race. What beat out the horse race in terms of policy? What beat out the horse race in terms of information or satisfaction or, you know, liking the democracy as we see it, kind of system support kind of stuff, you know? And then they go in and they look at all the things that were significant in those final regressions. And here's what I want you to tell me. Wait. Oh no, I copied the wrong thing in there. Shit. Okay, well, what this table was supposed to tell you was a different table, and it wasn't just opinion leaders. By the way, these are just white people. And there's a reason for that. That's not racism. Among the regular white population of the United States, trust in people went to zero. had no, it was strong in the bivariate, went to 0. And I want to understand, well, I fucked it up by copying the wrong table, so I can't even ask you these ones. Darn it. And in the other table, which I obviously don't have in front of you, do I have it here? How dare me mess that up? The perils of ADD, man. All right, well, maybe we'll get to it in a second. We're almost out of slides, so we'll get back to it. All right, I want to talk a little bit about F. And this is not because F test is necessarily always the best test for this, but this helps us understand the relationship between parsimony and complexity of models. And statistics in and of themselves and the way we model them are biased toward parsimony, right? Because otherwise we just stick everything in the model, and try to, estimate things with, 40 independent variables, and then just see what turns out, right? And F tests help us navigate that parsimony and tell us, is this worth the deviation from parsimony? Okay, so everyone's seen this before, right? Like we've got intercepts, and understanding intercepts is going to help us with multi-level models, because there's multi-level models that try to predict intercepts being different versus slopes being different versus both intercepts and slopes being different. And they all have their various combinations. And we're constantly trying to see, is allowing for all that complexity worth it? Okay, and so F tests help us understand that underlying logic. All right, so this makes sense to everybody. When you have a Y hat, and if I have low education and Matt, you have low education, and it's like the correlation between, or bivariate regression with education predicting political tolerance. Do you and I have the same Y hat? Do you know?
I would be guessing no.
No, we do.
Oh, yeah.
Y hats are on the line, right? Every single Y hat is exactly on the line. So if we have the same level of the independent variable, we have the exact same Y hat. Now, I may be more politically tolerant because I trust my fellow humans, and you're just like, nah, I'm not sure about those fellow humans. So you might have a negative residual and I have a positive residual. I have higher political tolerance than you might expect given my education. You have a lower political tolerance than you might expect given your education. If we're, if we're the same, and we're the same, we both have high, but, all right. So explaining R square has to do with understanding that, like, sometimes like this person, all these little X's are people, this person is on the line. So what is their value for residual? What is their value for E sub I? 0, right? They're not deviating from the line. Whereas this person is like me, I'm politically tolerant given my education. And this was like, somebody down here is like lower than you'd expect. And here we've got income and money spent on healthcare. I mean, it's just an example. All right, so we've got that for every person in our study, you've got a Y hat, which is just your value of the independent variable times the B coefficient, right, is Y hat. So everybody gets a Y hat. and there's not much variation of y hat, right? Like it, well, it depends on the steepness of the slope. These people, if they've got, they're deviating from the mean, and the distance from the mean to the regression line is y hat, is their value of y hat. Like this is what the slope has given us that the mean did not, right? And this person is above the line, and this is what the slope gave us, right? The slope gets us this far, but the residual, it takes a residual to get us the rest of the way, right? So you divide up all the variation into total variation, explained variation, and unexplained variation, right? Unexplained variation is the residual. Explained variation is a y hat. And total variation, another word for total variation, by the way, is just variation, which is the standard deviation squared. All right. So we get total deviation equals explained plus unexplained. All right. So this is the way it happens. If you've got a slope of 0, then everything is unexplained, right? All the deviation from the mean is exactly the deviation from the slope. So total variation is also total unexplained variation, and there's no daylight there, right? It's virtually identical. So R square is the model sum of squares to total sum of squares. So here we have a regression. Unfortunately, this is Stata, but Stata produces the same estimates as R does. We've got model sum of squares is 0.74. Total sum of squares is just you add up, you continue adding it up, right? And that divide by n is canceled out in both cases, right? So it's just, the proportion. So 0.748, blah, 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 divided by 45, blah, 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 is 0.01638, which matches 0.0164 in the R square over here. You see that? Adjusted R square is basically the same. But we're going to talk about adjusted R square in a second. All right, so got a little bit of a correlation. R square is this. Okay, so here's the logic of S-test. So we have, here's a fun little example. Confidence in what people see on TV. Turns out, so dependent variable, a lot of confidence, no confidence. Tube time is a variable of number of hours. You got to go. Okay, bye-bye, Kamal. Let me know if you have any questions. Don't forget to do the practice. Number of hours of TV you watch a week. School is the years of education. How much you like Japan is your feelings of Japan. And by the way, this is US residents. Your support for spending more money on national parks is here for Yellowstone. And whether you're my astrological sign, which is Pisces. Okay, so this is a, dummy variable. Now you probably know what I'm getting at, right? Like, what am I getting at here? These three variables are idiotic, right? It's hilarious because the GSS always asks everybody their sign, I think for the purposes of saying, this is not associated with anything or, whatever. All right, so some correlations between them. Notable, the amount of time you spend on TV is negatively correlated with trust in TV, which is kind of fun. School is positive, and these three, as you might guess, are basically 0, right? So now we've just got trust in TV is associated with tube time. And you've got your sum of squares, right? Your model sum of squares. And then you've got a residual sum of squares. And you divide that, and you've got an R square now of 0.031, you know? All right. Then I've got equation 3, where I add in some other variables, and look, my R-square goes up. And then I add in my astrological sign and how much I like Japan, and R-square goes up from 0.039 to 0.04. So therefore, I must be adding to our understanding, you know, and it does not. So what you do with an adjusted R-square is you adjust for the number of independent variables you've got in your model. And you're like, is this increase in R-square worth it from a parsimony perspective? Okay. So here's the calculation. You know, we've got an F test now. So we've got F is 8.6. And just like a T statistic, you can look up in the back of the statistics book, look at your degrees of freedom, look at your other degrees of freedom, and you can look it up. And so the significance of F there is the truth, given that F, given the N, and all that stuff. Okay. So we've got R-square is your degrees of freedom in the first model minus the degrees of freedom in the second model, you know, times the change in R-square. And now we've got 0.03. We used to have just the constant, which is the mean. And now we've added in 2 independent variables. And so is it worth it? We go from 0 R-square basically to 0.03, and it turns out to be significant. So the cool thing about an F test is that F test can tell you, is this group of variables adding to our understanding? Now, how is that connected to how we started the day? The loose conceptualization, right? All the variables that fit within a category, we might want to know, do these together add to our understanding, right? So here's what the F test is. It's similar to, you know, adjusted R-square. You account for the loss of degrees of freedom. Do y'all know what a degrees of freedom is? It's your N, your number of observations, minus your number of variables, minus 1, which is the constant, you know. All right, now we're going to add in, you know, liking Japan and my astrological sign and all of these things. And we're going to say, okay, so we've changed from 2 to 6 predictors, and now F is 0.3. And if you look 0.3 up in the back of a textbook, it will tell you that is not significant. So here's a cool application. Cool application is this study done by Engelhardt, Granado, and LeBlanc. Y'all heard of Engelhardt? Ah, look at all that fun. Okay, good. My professors in grad school all couldn't stand him, but he, you know, thank God for the World Value Survey. So like, I wouldn't want it to bite me in the ass that, like, you know, nevertheless, people didn't like him, but whatever, you know. So they asked the question, does culture, which is an idiotic word, contribute to economic growth? Now, why do I say calling it a stupid word? Because I'm, you know, in a mood. Why do I not like the word culture?
Because of the conceptualization.
Yeah, it like, what in the hell is culture? Culture is a set of so many fucking variables that you can't put them in a category, right? It's just stupid to put them in a category, but whatever. They wanted to know whether attributes of countries that would be predicted by mean levels, does that add to our understanding of economic growth, you know? So they put in all the variables that economists have agreed on that predict economic growth. And then the next step, they put in mean levels of support for the rule of law, because they read Douglas North, who won the Nobel Prize for saying support for the rule of law can help bring about economic growth because it reduces transaction costs. I don't know if y'all read that, but I am like a fucking, fan of the North Weingast whole slew of stuff. I mean, whatever you might want to say about them, thank God for them. They've increased our understanding of stuff a lot. All right, but nevertheless, they added country level estimates of rule of law and trust, and voila, the F test was significant. So take that, you economists. You think you're all special. So can you think of any examples where you might want to do an F test, like a nested model where you test a basic and then see, did these things add? Can you think of something you might want to do? Like I might want to add in every fucking economics variable, and then see if my non-economic suffering adds. And I might want to turn around and do the opposite, add in all my life suffering and see if economics adds anything significant to the model, right? That might be something I might want to do. In a sense, you could think about interaction terms being, they've got T also, but why are interactions particularly likely to not be significant? They almost never are. If you're fucking around, just looking around for interactions, you're not going to find one. They're not easy to find. Although I have a double secret command in Stata that looks for all of them, and they just invented one for R too, so I could tell you about that one too. Now, having said that, sometimes it's being conservative to look for every interaction between variables, to look to say, do these set of variables interact with any other fucking variable I have in this data? Sometimes it's more conservative to search high and low for interactions, nonlinearities, everything you could find. Why would that be? Because everyone tells you, well, you better have a theory first, right? Don't just go poking around looking for significant effects, right? So why would that be advisable in certain circumstances, particularly mine in this case that I told you my interest was? If I want to say something's not significant, I better fucking look around, right? I better know, does divorce interact with bad economic situation? It doesn't, right? In order to say we're overestimating the impact of economics on people's considerations, I better have my ducks in a row, and I better have looked around for every possible thing, just like I collected every possible variable I could think of about people's economic situation. I got to try to prove myself wrong. And by doing so, I try to explore every possible interaction, right? So that would be an example of, being more conservative with my estimates. Another way of loss of parsimony is to take a scale that's ordinal and dummy them all out, right? Dummy out every single party ID variable, right? As a way to lose parsimony. But it better be worth it, statistically speaking. But why are interactions hard to find? Hard to identify? Like, why are they almost never statistically significant? starts with an M. And we've talked about it a lot today. And it blows up your standard errors like madness.
Multicollinearity.
Multicollinearity. I mean, when variables are a product of each other, they're going to be correlated. You know, they're going to be more correlated. And I'm glad for that. I feel like if you're going to do an interaction, you're going to deviate from parsimony, it better be worth it, you know, is what I would say. But can you think of a reason for grouping variables together in your own research and saying, we're going to, you know, those are the ones everyone knows about. Now I'm going to see if my ideas contribute something significant.
Maybe we're trying to looking for alternative explanations, or we want to test new hypotheses as well, because we have developed a theory, something like that.
Yeah, exactly. Exactly. Like, you know, you want to do what Granado and those folks did, which is like, we're not just trying to shoot in the dark here and just say that, look, our variables are significant. We're going to say, we're going to give it all to economic, you know, growth, the normal variables, right? And then we're going to see if these variables, if we add them in, do they change our square significantly? And that's a hard job when you're starting out with a big R square. It's a really hard job. F-tests are easily significant. You run a regression between anything that's got a correlation of 0.10, and you're going to have an F-test that's significant in the first model. But the and probably Andy Phillips talked about ways, and have y'all taken MLE or done Probit stuff? Don't y'all do like likelihood ratio tests? You know, and you compare nested models to one another. A log likelihood is a non-OLS way of testing a similar type thing. All right. I mean, if we start with the big question of we want to know what makes people identify the humanity in people they don't like or seem weird to them or whatever, right? You put in some of the normal, well, I'm, you know, competing with them economically, where, you know, they're going to take my jobs or, you know, that kind of thing, right? And then you'd want to add in other explanations that add significantly. So one place that this happens, who does right-wing voting in Europe, comparative speaking? Was that you, Gustavo? I can't.
Me.
No. Oh, that's you, Matt.
It's Matt.
Okay, so yeah, so you're going to read the Lauren McLaren kind of stuff, where, you know, she and her various co-authors, one of whom is me, because we're friends, she's great. She wants to say, okay, so yeah, economics explains some anti-immigrant stuff. Put that stuff in the model, and you add in the symbolic, I don't want taco trucks in my neighborhood, and that accounts for a great deal of variation that economics wasn't explaining, you know, something like that, right? So she wants to understand, well, what are the symbolic impacts on what makes people, you know, what makes people go, nah, you know, I'm not threatened by them, but like, I just don't want them around, you know, kind of thing. And if there's people like that, and it's not really because they're looking around feeling economically threatened, then that tells us that there's something else going on, that there's a xenophobia beyond economics. I'm on a quest to bury economic variables. Not because I have anything out to say about them, but I just don't think people think that way. I think people think other people think that way. But I think people are like, well, I'm not a selfish person, but right? Like, and so they don't feel good about being selfish, but it's not because I dislike rational choice or because I don't at all. I just told you I love Poindexter North. Okay. So more slides for geeks. So let's talk a little bit about the comparative method. So y'all know Gabriel Almond. He wrote the Civic Society with that sweetie pie Sid Verba, or probably Verba, but I'm a German speaker, so I say Verba. Around that same time, maybe in the 70s or 80s, Almond wrote this great essay called Clouds and Clocks, or Clocks and Clouds. And he's talking about the difference between quantitative and qualitative and why it's so important to consider the clouds, like the stuff that you can't easily nail down quantitatively, because we'll lose the battle in establishing quantitative if we become fucking assholes. He doesn't say that, but he says, like, we're going to lose our ability to explain important phenomena that cannot be accounted for, by what we have the ability to measure. And he's like, if we want to understand political science, then we have to understand institutions. And institutions are caused by all kinds of things that we cannot measure. Why did South Africa ask a political scientist how they should write their constitution? Does anybody know? Because I fucking don't, but I'd like to know, because Israelis literally came to the United States and had big conferences on tell us what our electoral system should look like. And then they did the opposite of what we suggested to them, right? But South Africans, they were just like, yeah, let's learn, let's figure out a way. And you know what? It stopped everything that was on its way to happen. It was going to be massive violence in 1994. And there was massive violence, if anybody knows about it. It was a shitty time to be there. But it would have been a lot worse if they hadn't come up with, well, let's have 3 presidents that represent the main portions of society and give people a reasonable veto on legislation. They brought in Leipart, who's wrong about a lot of things, but that was one place where political science actually helped the world. And why that happened, it's probably because Nelson Mandela's a sweetie. I mean, that's, it's a random ass fucking thing that he happened to be a sweetie, and that's in the clouds, right? That's in the, you can't grab a hold of it. You don't really know what's happening there, but we're going to have to, account for some of those endogenous factors if we're going to understand the impact that these institutions have. So was it Nelson Mandela's sweetie pie-ness that saved South Africa from violence? Maybe, he's a confounding factor, that he didn't hate his prisoners and, was all, was a Buddhist and his, way of being or whatever, like, don't lash out at them. They're just doing their job, or, I don't know if I could have that kind of humanity. And that's like in the clouds. Like, so, would the consociational regime have saved South Africa's shit without Nelson Mandela? But maybe Nelson Mandela caused the consociationalism, which helped bring about, we don't know. And so that's why the qualitative stuff is so important. Okay. So, and I already told you, I think the existence of American politics as a field is a logical fallacy. So, like, I'm a comparativist as my social identity, even if I'm not rostered as a comparativist. It's in my bones. It's in my, everything about the way I think about things. So this is going back to Przeworski and Tooney, who were just geniuses, the logic of comparative social inquiry. Have y'all read that? Has anybody read that? Y'all gotta read, you gotta read it again. It's a great work. So they identified a couple of things, which is get rid of proper nouns and establish the difference between countries on conceptual terms. Like name the concept, scale it, figure out its interval level, figure out its ordinalness, figure out like what's going on, like what do you have to dummy out? Because you can even dummy out things without calling stuff Germany, right? So then they identified two ways of establishing what causes, what allows us to compare across countries, okay? One is the most similar systems design. I don't know if you can think of one, a most similar systems design.
As an example?
Go, please.
No, it's like two cases that are similar in almost all variables, but one, and we would like to see the difference between those cases.
Exactly. So you try to control for other factors by eliminating their variation. And then having variation on two different things, then, you can say that, like, my favorite example of this was a comparison between the litigiousness in Holland and the lack of litigiousness in Germany. They looked at all of these aspects of their legal system, their history. I mean, the Dutch like to pretend they don't speak German, but I can read Dutch. So that tells you that, that it's pretty similar language, okay. So, but I don't want to annoy the Dutch on the call here. If I have anybody here who's feeling upset about that, but they're very similar peoples, and yet the Dutch are completely litigious and the Germans are not, and the question is why? Well, they did some causal process tracing and try to figure out, well, where are the Germans going? And they're going to their bureaucracies, because Germans have trust in government and don't trust corporations, whereas Americans are the opposite. They're like, take my data, but government, get out of my life, or whatever, so so like they had other mechanisms for resolving their disputes before it gets to litigation, whereas the Dutch had the absence of that. And so they just didn't have an institution that allowed for that. I mean, we don't either in the United States. If the corporate world comes along and, pours fracking waste in your backyard, do you know what you can do? Nothing but sue. And you can't sue until your health is fucked up and it costs you some financial money, right? Like we've got a system like that lends itself to that stuff. And then a really fun, most different systems design was my data one paper that, here I am bragging here, but really it's just because I had data that ended up in the APSR, which is why I got this job. But it was the most different systems design in which we put a bunch of European countries, which at the time people thought of as different from one another, and some Eastern European countries in the US and Canada, and we put them all in, and we noticed that awareness of the legal system predicted support for the legal system. And it also, like, people who are more aware are more blinded by this, well, they're after justice. Because if you have two eyes and can read, even before Dobbs was, decided, you're not thinking, oh, politics has nothing to do with the court. I mean, they're just, interpreting the law, like if you have two eyes and you're looking at it, but all these lawyers will tell you all day long that they're just interpreting the law and there's doctrines and they're looking at the doctrines and that's what's causing the outcomes. And it's like, what? And the more aware you are, the more you believe the bullshit. It's kind of an interesting finding. And guess what? One population stands out, which is African Americans in this country. The more they know, the more they hate the system. It's kind of an interesting, well, why are they different? Scenario that would be super interesting. But, we looked in, we tried to maximize the difference in all of this data, thinking that Poland in 1991 is pretty different from Spain in 1991, which is pretty different from the US, which is pretty different, not really that different from Canada, but, they're all different from one another. And so if you look at that, we saw the same relationship across the board. And even with all the coefficients being statistically significant, we found that the length of time that the country had been a democracy predicted those coefficients, which is kind of an interesting. So it was like a little bit of a mixture there. But when you're thinking about things, it's not just countries that you want to rule out, right? So like one of the things that I'm interested in is policy areas at the Supreme Court. So like my unit of analysis in my book was policy area .year across 40 years. And I'm interested in what makes economic kinds of litigation different from the civil liberties, civil rights system, right? But you can also look at differences between First Amendment and privacy, or civil rights type, racial discrimination type cases. You could so in my book I ran what's called a fixed effects model, which control for dummy variables of each policy area, right? Because I wanted to make sure that the effect I was looking at happened within each policy area. What that does is it removes a lot of the interesting variation that can co-vary between these cases. So in my next book, which I will never write, I've got a little paper that I'm trying to publish that says why the Supreme Court cannot make liberal economic policy. Is trying to say, okay, liberal economic litigation is different from all the rest. So it's kind of an interesting thing. And do you see how that's got an analogy to the most similar, most different systems case, where I've got some most similar systems between civil liberties and civil rights, and a most different systems and the economic cases. And so they don't have to be countries, in other words, that you're establishing this. I mean, in other words, you could run a multi-level model using effects that are nested within racial categories, and so don't dummy out the racial categories, allow them to co-vary and see, where they are similar and where they're different from one another. So that's kind of my point about that. Let's see, where are we? We're out of time, and I've got some additional slides. So let me just stop my screen share, and I'm gonna show you my our practice problems, which you could do. You don't have to do, but we're going to go over them anyway, because I want to make sure. Wait a minute, do I have the wrong? Oh, it is wrong. So basically, these are a bunch of, oh, y'all can't see. So, I've got some various hello? Oh, y'all can, okay, you're good. All right, everything's weird. All right, so I've got some regressions, and then I've got like some things that I'm pointing out where I'm like, okay, which of the following are valid? So you have to select. They're, you know, they're each yes or no, valid or not valid. So there's some select all that apply, and then there's ones that are just one answer. So I wanted you to be aware of that. And I've got some graphs, and look at this, and tell me what these coefficients mean, and, you know, that kind of thing. So there, you know, so there's just a few things, and I wrote these to prepare you for what's to come. So it'd be a good idea to at least look at them if, you know, if you want to, and let me know if you have any other questions or anything.
So yeah, question. Are we going to be given the data set for us to run and code the regressions, or is,
Yes,
or are
but
we
not
going?
today.
Okay.
Oh, do you want these data?
Sure, why not?
Yeah, in fact, I think it is actually right now in the data. And oh yeah, it's right there. The
Okay.
data I used for that, for creating that, is right here. But y'all should just be aware, I have this other Baird data and documentation, which is, here's all my Supreme Court data, here's all my CCESs, and they're all clean, which, if you know what that means, it's extraordinary. I cleaned the fucking GSS. It nearly gave me a heart attack. I'm going to die an early death cleaning that fucking data. There are 6,000 variables in that data that I had to clean, label, normalize from 0 to 1. So it's just like, it's there for you to just look at. And there's 50 or 80 exogenous variables in there about attributes of people's life growing up. I mean, a bazillion attributes. It's an incredible data set. And then I've got, what else do I have in there? All the world values, 100% clean. A few ANSs that are reasonably clean. Some other replication data that I've downloaded along the way that you could, you know, poke around at. This might be the LeBlanc. That might be the LeBlanc paper I was talking about, but I don't know. There's some various panel model data that I've put in there for you to poke around with if you want. So there's a lot of stuff you can do, and I'll be including other data sets with some assignments where you're going to actually go run the data. Today was like the baseline, make sure you understand to interpret some basic models. And then I'm going to be posting some experimental data and some multi-level model and some world values. The world values is in there. Yeah, there's the world values. And the world values, by the way, they themselves attached a bazillion country level data to those data. So you know all the bad and good data that are out there that are country level estimates of stuff. And it's all inside that database. So that's super cool. Support for political violence, support for flouting the law. Like, there's a lot of very cool stuff in that database. It's not great for independent variables, but it's a great data set. So, and everybody has had that for a long time. So if you need me to reshare all these clean data sets, I'm happy to. All right, I'll see you tomorrow, bright and early.
All right, thank you so much.
Well, not bright and early, 10, but you know.
Dr. Baird, sorry. For me, I have a medical appointment tomorrow, so maybe I won't be able to attend. Nevertheless, I'll watch the recording.
Perfect.
Thank you very much.
Okay, all right. I hope y'all have a good
tomorrow.
afternoon.
Thank you so much.
Yep, you bet. All right, and I'll stay on in case anybody has questions. Yep, good. All right, baby, we are